Okay, hi, we've moved out of the danger zone and a little bit further south along the Stanley Park seawall. We're still in the same rock unit. This outcrop looks a bit different. I think we've had a fresh landslide at some point in the recent past here, which has exposed the rock, so it appears differently, but the rock unit is the same. We're looking at the Nanaimo group, which is Cretaceous in age. And again, you're going to be exploring this unit in more detail tomorrow. What can we see here at this outcrop? We can see a very muddy looking sedimentary rock. At the top, perhaps you can see a line halfway up the outcrop with maybe some pebbles up there and some cross bedding below. So we have these lines at an angle to the bedding, which we call faucets, and they indicate a unidirectional flow. We're going to explore that in a lot more detail this afternoon. You can see there's some rubble of this rock which has fallen down, and if you have this, it's always worth looking at rubble in the field because it's like having a hammer. It's just broken the rock into pieces. Sometimes it breaks along bedding planes, and you can find interesting things like fossils sometimes, or more fresh detail of the rocks. So if we look at one of these blocks that has come off, it's broken off probably along what was the depositional plane. I don't want to call this a bedding plane because we don't know if this formed one bed, but this probably was the depositional plane, and you can see these oblique angled darker lines. These are faucets, and that defines cross bedding. When we're interpreting it in the field, the direction that these faucets are dipping gives us the paleo flow direction, and we're going to learn more about that this afternoon. So if you look at those up there in the rock face, those are dipping towards, I don't know what the orientation is here, but they're dipping towards the left of the video, so the paleo flow direction would have been in that direction. And it's a coarse sand, that was. It does have a muddy component as well, but the dominant grain size was coarse sand. If we move along this way, now we can see another part of the outcrop which is in situ. So now we're not looking at the rubble which has fallen down, and we can actually access these layers. So down here we have another unit which is medium to coarse sand. When you look up close, it's certainly finer grained than the stuff that appears on the top. It may be cross-bedded, so we can see these oblique dark lines. We might call them laminations in the rock. To know whether they're cross-bedding, we need to know what the bedding plane is and know whether they're oblique to that, because they could also just be horizontal laminations and then this unit has been tilted. The bedding here is again not super obvious because we're on a coastline and this rock unit has been weathered, but you can see a horizon here where it goes from finer grained below to coarser grained above. So about there where my finger is, and you've got a line of pebbles and then it's coarser grained above. That would be a bedding plane. So it demarcates one depositional event from another that came in here. So this would have been one flow or set of flows, and then another came in with coarser grained material that formed perhaps an erosional surface there, deposited these pebbles. I wouldn't call it a class-bound conglomerate because most of the rock here is still sand, but it's certainly a sand containing some pebble-sized grains. The bedding here, I wouldn't say that this is a good enough outcrop to measure the bedding. Because to measure the bedding, you'd need to really see what that plane looks like in 3D. I can only see that interface in 2D. So you could get an apparent bedding measurement, how it appears in this plane, but you wouldn't be very confident that you're measuring the precise strike and dip direction of that bedding. But they do here dip towards the south. So as we're going from one locality to the next along this tour, along the Stanley Park seawall, we're going from older, deeper stratigraphy to younger, shallower rocks. So that way is getting younger, and going up is getting younger as we go through the stratigraphy in time. Let's talk briefly about what might create this change in bedding. So you could go through an exercise in the field of describing this sedimentary rock and say we're going from a coarse, medium to coarse sand with potential cross bedding, then we have an erosional layer, which we would define as our bedding layer, and then we have pebbles supported in a matrix of sand above. That's a good description, but when we're doing field geology, we also want to be thinking about interpreting the processes and the environments that could have formed this in the first place. So why do we have that variability? It's probably due to a change in the flow that created that sediment. So if you have an erosional unit that comes in and then a coarser grained unit on top, perhaps we had a faster, more powerful flow that was capable of moving larger particles. If they have more mass, it takes more energy, a higher flow velocity to move them. And we're going to think about this concept more this afternoon. So interpreting sedimentary rocks like this with indicators of unidirectional flow like crossbedding, and how we can invert that for information about paleohydraulics. So we want to try and get quantitative information out of the outcrop, and we're going to be thinking about those principles later. But this is the Nanaimo group. It's another nice locality, and you could come and look at this in Vancouver.